Okay, starting 1.4, solving absolute value equations. Okay, absolute value. What does it mean? All right, let's refresh your memory here. Absolute value of 6. You got these two vertical bars next to the 6. Absolute value simply means the distance a number is from 0. When you calculate distance, that's always positive, okay? So how far is the number 6 from 0? Well, it's 6 units. Now, if I take negative 6, the absolute value of negative 6, how far is negative 6 from 0? Well, it's also 6 units. So whenever you're taking the absolute value of a number, the result is positive. Okay, that's the first thing you understand. Now, what if you had something like this? Absolute value of x equals 6. All right, well, what numbers could you have in here where the result would be 6? Okay, well, I could have 6 inside here. What else could I have? I could have negative 6 inside here. And the result for both would be 6 because you're calculating the distance you are from 0, which is always positive. Okay, so whenever you're taking the absolute value of a number, the result's positive. So applying that logic to the first part, the first problem, example A, let's apply that here. So x minus 4, the absolute value of it, is equal to 6. All right, now, what did we say before? All right, well, I'm taking the absolute value of this. The result is always positive. Now, in order for me to get the result 6, x minus 4, what must it be equal to? Well, it must be equal to 6, or x minus 4 could also be equal to negative 6, because if you take the absolute value of either one of those, the result is 6. Okay, so how do you work this out mathematically? Well, you set x minus 4 equal to positive 6, because this could be equal to 6, all right, and that will give you a result of 6. Or you set x minus 4 equal to negative 6, because x minus 4 could be equal to negative 6, and if we take the absolute value of it, we once again get 6. So solve each one of these equations separately. All right, once again, if you're having trouble with problems like this, please ask me for help, because this is going to come up again and again throughout the school year, and you want to make sure you have this down solid right now. Okay, so they also ask you to graph the solutions on a number line, so this is really simple. You're on a number line, there's negative 2, there's 10. Just put a dot there. Put a dot there. That's your solution if you're graphing it. All right, that's all there is to it. Let's go to part B. Same deal. What must 3x plus 1 be equal to in order for the result to be negative 5? All right, well, let's think about what it means to find the absolute value of a number. If I take the absolute value of a quantity, the result is always supposed to be what? Positive. Well, that contradicts what we see here. It's negative. Now, how can that be? Well, it can't be. All right? Since it can't be, that means there is no solution. All right? Once again, because if you look at this problem here, you're taking the absolute value of this. And when you take the absolute value, it results in a negative number. Can that be? Is there any value of x that'll give you such a result? No, because when you take the absolute value, the result is supposed to be positive, but here we see that it's negative. So this can't happen. There's no solution in this case. Okay, next examples should go a bit faster. All right, first thing, all right, before we start setting up the positive and the negative cases, we first have to isolate the piece with the absolute value. So what am I going to do here? I need to get rid of this. What do? Add 10 to both sides. Cancels out on the left. So now I have absolute value of 3x plus 9 is equal to 6. All right, now it's the same thing that we did before. I know that 3x plus 9 must be equal to positive 6. It could just as well be equal to negative 6. All right, just want to emphasize this idea once again. I could replace 3x plus 9 with 6, and my result would be 6. I could also replace it with negative 6, and my result would be 6. All right, so I have my two cases here, my positive case and my negative case. All right, let's solve each of these. We got x is equal to negative 1. And I have x is equal to 1. Wait a second. What? What did I just do here? Okay, I don't want to do this all over again. Eraser tool. What was I supposed to do here? Not add, subtract. Duh. Okay, supposed to subtract. All right, so I have 3x is equal to negative 15. Divide by 3. X is equal to negative 5. All right, caught myself once again. Extra credit for Mr. H. So here are my two solutions for this problem. On to the next example. All right, solving equations with two absolute values. Okay, now a lot of students freak out when they see absolute values on both sides of the equation. They're like, what is going on here? All right, now, when you have more than one absolute value, don't even really worry about the second absolute value. Just imagine it wasn't even there, because you're essentially going to do the same thing that you did before. So I'm going to do 3x minus 4 is equal to the positive case, x, and 3x minus 4 is equal to the negative case. All right, x. All right, so just think about it as if the absolute value wasn't even really there. Okay, so let's solve each of these. I'm going to subtract 3x because I want to isolate x on one side of the equation. Divide by negative 2. And I get x is equal to negative divided by negative is positive. And then on the right side here, I'm going to subtract 3x once again. Use a blue. Negative 4 equals negative 4x. Divide by negative 4. And x is equal to 1. So my two solutions here are x is equal to 1 and x is equal to 2. All right, let's go to the next example. I think I could squeeze it in here. Actually, I'm going to write it down here. I'm doing part B down here. All right, so I got absolute value of 4x minus 10 is equal to 2 times absolute value of 3x plus 1. Okay. All right. So same deal as before. Okay, we're just going to take the 4x minus 10, set it equal to the positive case for this absolute value, which is just 3x plus 1. And then we also have to set up the negative case. All right? So you take the negative of whatever was in the absolute value. So it's negative of 3x plus 1. All right, don't get freaked out by the brackets. Brackets are just like parentheses. It's just for the purpose of organization. Okay, let's solve for x. I'm going to distribute here. I'll get 4x minus 10 equals 6x plus 2. All right, I like to have my x on the left side whenever possible. So I'll isolate it, in this case, on the left side. Okay, x is equal to negative 6. All right, for the next one, I have, all right, there's a lot going on here. You got to be careful. Oh, we got these negatives here. All right, watch out for the negative, because that always messes students up. 50% of the mistakes typically are because of the negative. So I have negative 3x minus 1. Now I'm going to distribute 2. All right, just take it step by step. Be careful. All right, sometimes by rushing through the problem, you make a mistake, and then it takes you even more time to do it had you just written everything out, which I'm doing right now. All right, divide by 10. I got 8/10, which also reduces 2. Divide both these by 2. 4/5. All right, so x is equal to 4/5, which is also equal to 0.8. So that's one answer. This is another. You can put it in decimal form or fraction form. All right, and on to the next example. All right, so identifying extraneous solutions. Okay, so here it tells you to check your solutions. In the previous examples, it didn't tell you to check them. All right, so this isn't much different from what we've done before. I got to take the positive case, so just 4x, and then I also have to take the negative case, so negative 4x. All right, let's solve each of these. All right, subtract 2x here. All right, moved it over to the right side because it just makes it a bit more simple. So x is equal to 6. For the next one, I'm going to subtract 2x. 12 is equal to negative 6x. 10 divided by negative 6. And I get x is equal to negative 2. Okay, now I have to check my answers. Let's watch what happens here. 2 times 6 plus 12 equals 4 times 6. Does that work? I get 12 plus 12 equals 24. Here I have that absolute value of 24 equals 24. Absolute value of 24 is 24. So that's true. That checks out. X equals 6 is a solution. For the next one, let's plug negative 2 in. So I have 2 times negative 2 plus 12 equals 4 times negative 2. So I have negative 4 plus 12 equals negative 8. Now I have 8 is equal to negative 8. All right, so the absolute value of 8 is 8. And is that equal to negative 8? No, that does not work. So x equals negative 2 is not a solution. It's known as an extraneous solution. That means that it's a solution that you get, but when you check it, it doesn't work. So it's not really a solution. So the only solution to this problem is x equals 6. All right, on to the next example. All right, here we got two absolute values once again, but don't freak out because we just have to take the positive and the negative case of whatever that quantity is in the second absolute value. So you do x plus 5 is equal to positive x plus 11, and then do x plus 5 is equal to the negative of x plus 11. Now you got to make sure to put parentheses around it because you're going to have to distribute that negative, which a lot of students forget to do. Watch out for that. All right, so I need to isolate x here. I'm going to subtract x, and something happens. 5 equals 11. Huh. What does that mean? All right, now, does 5 equal 11? No. So in this case, there's no solutions that could be obtained for this equation. So we go to the second case. All right, now let's try to isolate x. Get it by itself on one side of the equation. All right, that's it. All right, we get x equals negative 8. So that's the only solution to this equation. All right, that's it for the lesson. Go to the bottom of the web page and start lesson 1.4 or assignment 1.4. Make sure to ask questions if you have any.